All right, we're going to continue with talking about circles. And today we're going to talk about tangent lines. So you've heard the word tangent before in this class when we talked about trigonometry, sine, cosine, and tangent. But it's not the same thing, so I don't want you to get confused. They use the same word to talk about two different things. So tangent lines are something completely different from the tangent in sine, cosine, and tangent. So just keep them separate in your mind. What we're going to look at is when a line or a segment touches the circle on the outside. Okay, that's basically what we're talking about. Okay, so a tangent line is a line that intersects a circle or touches a circle at exactly one point. Okay, a tangent line touches one time. This is extra information. If it touches twice, like if it cuts through the circle, we call it a secant line. Okay, we're not specifically going to deal with secant lines. But a tangent line touches one time, and it touches at the point of tangency. Okay? So in my little diagram here, we could say that AB, line AB specifically, is tangent to circle P. So if you name a circle, that's kind of how you name it. You name it by its center. Okay? And then point A is the point of tangency. It's the point where the circle intersects the line. Okay? Now there's a theorem and a converse of a theorem that we have to use that we're going to talk about today. So if a line is tangent to a circle, so if my line touches my circle one time, then the line is perpendicular to the radius drawn to the point of tangency. So here's what that means in not math talk. If this line touches the circle one time, then where the line and the radius of the circle intersect right here, it's going to make a 90-degree angle. Okay? If that angle is anything except 90, then this line is not tangent. Okay? And the converse of that means we set the theorem backwards. So if a line is perpendicular to a radius at its endpoint on the circle, then the line is tangent to the circle. So in other words, say it backwards. If this angle is 90, then the line is tangent. If it's not 90, it's not tangent. Okay? That's what those mean. So here's our idea today. We're going to kind of make us a triangle in here. And it's going to sometimes be a right triangle, sometimes it won't be. And we're essentially going to use Pythagorean theorem all day today to look at some things. Okay? So remember Pythagorean theorem. Oh, let me see down here. Okay, so we're going to use a squared plus b squared equals c squared all day today. So this is our tool for today. So we're doing the second part first, the converse. Determine if the line AB is tangent. So I want to know if this segment right here touches the circle one time. So the first thing I do is I want to look for where this 90 would be. Okay? And judging from my picture, it's going to be right here. If it's 90, it's going to be right here. Okay? I don't know that it's 90 yet. Okay? So keep that in mind. I don't know it's 90, but I'm going to think it is, so I'm going to draw it in. Okay? And if that is 90, then I essentially have a right triangle. Okay? And if I have a right triangle, then that is supposed to work. The Pythagorean theorem is supposed to be true. And so what we're going to do is we're going to see if it's true. Now, to use it, we have to make sure we have all three sides of the triangle known. And this is where it gets tricky because sometimes they'll give you a piece of the side and you have to find the whole side. So here's what I mean. We have this entire length of 17 given to us. That is across from our 90, and so that's going to be our C, the hypotenuse. 8 was given to us. That can be, A or B or whatever. It can be A or B. But then look here, they only told us this section is 7.5. That's actually our radius from the center to the edge. That's our radius. They told us it was 7.5. But I need the whole thing. I need the diameter because that's going to be a side of my triangle. Well, how long is the diameter going to be? Well, the radius is 7.5, and then we know that this radius is also 7.5. And two 7.5s are going to make 15, because 7.5 plus 7.5 is 15. Or 7.5 times 2, however you think about it. So I'm actually going to use 15 for that whole side length. Okay? Now I'm going to set this up and see if it's true. So 8 squared plus 15 squared. And I'm actually going to put a little dotted line there because I don't know if it's equal or not yet. Okay, I don't know that it's equal. So that's just the way I do it. Now we're going to simplify all this. So you can just type all this into the calculator. 8 squared plus 15 squared. You type all that in. You get 289. 17 squared is also 289. So these are equal. So that they're equal, so the Pythagorean theorem is true. So here's your thought process. You set this up and see if it's equal or not. If it's equal, then the Pythagorean theorem is true, which means that is a right triangle, which means that this AB is tangent. So you can just put is tangent. So bottom line, if it is equal, it is tangent. And you can probably figure out what it's going to be if it's not equal. Is equal, is tangent. Okay, that's kind of all you have to put. So same thing over here, same process. Now the actual work might look a little different. So where's my 90-degree angle at? It's going to be right here. All right. So let's make sure I have every piece I know or I need. I know this side of the triangle is going to be 8. This side's going to be 15. But then look here. I know this exterior piece is 11. I need to know how long the interior piece is. Well, now notice that this piece is from the center to the edge of the circle. That's another radius. Well, I know this section is 8. That's also a radius because it goes from the center to the edge. So that makes this 8 also. In case you hadn't figured it out, all the radii of your circle are equal. All the radii are going to be the same length. So then, what is that whole length? 8 plus 11, that's 19. And so we'll set up Pythagorean theorem. 8 squared plus 15 squared, divide it, or separate it, 19 squared. Type all that in, you get 289. 19 squared is 361. Those are not equal. Matter of fact, it is less than. And you could put the less than if you want to. Bottom line, that's not equal. So guess what? This is not tangent. And that's really it. So you do all this work. If it is equal, it is tangent. Not equal, not tangent. Pretty simple. So the only thing here that could trip you up is if you don't know Pythagorean theorem, this is going to trip you up. You got to know that. Then you have to make sure to get every side of the triangle labeled so you can do Pythagorean theorem. Right, and here's the second half of what we're doing. So now you already know its tangent. So we automatically know that right here is the 90. We're still going to use a squared plus b squared equals c squared. But now we're actually going to find some missing links. Okay? So one of these, A, B, or C, is going to be missing, and we're trying to find it. All right? So, again, make sure you have every piece of your triangle that you need. You know this section's 9, that length is 9. This length you're trying to find, okay, so it's sort of theirs. That's actually going to be the C, the hypotenuse, because that's across from 90. But then look here, they just told you this much was 6. So the radius here is 6. From the center to the edge is 6. But I need the whole thing. Well, I know that's going to be 6 again, and 2 6s is 12. So I'm going to use 9 and 12 for A and B, and I'm trying to find C. So 9 squared plus 12 squared equals C squared. You could do X squared, you could do question mark squared. I don't really care what you use. You could use X, I don't care. All right, to save myself some time, I'm going to type all that in at once. And if you do that, you get 225. All right, and then I have to take the square root. And it should be perfect if I remember. I think everything I gave you today is going to be perfect. So that whole length over there is 15. Okay? Same process here. I'm trying to find this side right here. I'm actually going to let that be A. My personal preference, okay? If I'm always trying to find a leg of the right triangle, which right here is my right triangle, my right angle, I always let the unknown leg be A. I just like it to come first. That's just me. I know that this piece is 4.9 and that's 3.6. Well, what is it going to be together? Because I need it all together. So you add 4.9 plus 3.6, and that gives you 8.5. That's going to equal C, our hypotenuse. What's this going to be? Well, it's going to be 3.6 because it's a radius, just like this 3.6 is. Now I have every side of my triangle known, so I'm going to go ahead and set it up. A squared plus 3.6 squared equals 8.5 squared. So A squared plus 12.96 equals 72.25. Now I'm going to subtract 12.96. That gives me 59.29. Take my square root, and that's going to give me 7.7 when you type that in. And that's it. That's all we're going to do for tangents. There's a lot more that I could have done, but for time's sake, I just wanted to do these two. So make sure you watch this all the way through, complete your homework assignment, and as always, if you have questions, just let me know.